we need to determine the coordinates of the end center and the centroid of a triangle formed by the three lines whose equations are given to us. Okay, let us begin. Now here, let's go to the formula that we'll be using here in order to find out the coordinates of the end center and the centroid of a triangle. Let us suppose we have a triangle ABC with the coordinates of the vertices given as x1, y1, x2, y2, and x3, y3. Then the coordinates of the centroid can be obtained by taking the help of this formula. So what we do, we take the sum of the x coordinates of the vertices A, B, and C divided by 3. That's going to give us the x coordinate of the centroid. And to determine the y coordinate, all we have to do is sum up the y coordinates of the vertices A, B, and C and divide the result by 3. In order to find out the coordinates of the end center, there are a few more information that we need. We need to consider the side that is opposite to that of the vertex A, which is BC. So here we are going to suppose that let BC that be equals to A units. Then CA is going to be the side that is opposite to the vertex B. We're going to represent it by taking B in lowercase, and the remaining side AB, that is going to be the side that is opposite to the vertex C. We're going to represent it by taking C in lowercase. Now in this case, the coordinates of the end center, that is going to be given by, so here we have ax1 plus bx2 plus cx3 over a plus b plus c. So that is going to be the x coordinate of the end center, and similarly we can find out the y coordinate. That will be a times y1 plus b times y2 plus c times y3 divided by a plus b plus c. Now in either of the two cases, what we observe here, whether we find out the centroid or the coordinates of the end center, what we need is the coordinates of the endpoints, or the coordinates of the vertex A, B, and C. Now in our case, we are given that a triangle has been formed by 3 of the lines. So the equation of these 3 lines are given to us. So what we'll do, we'll consider that each of the side represents the line whose equation is given to us, and we'll try to solve 2 equations at a time to obtain the coordinates of the vertex. So let's begin. So we again begin by considering the triangle ABC, but this time we are supposing that the side AB of the triangle, let's say it's denoted by the line having the equation 3x minus 4y equals to 0. Next, we're going to consider the side BC. Now let us suppose that BC is represented by y minus 15 equals to 0. And then we have the remaining side CA. So CA is going to be represented by 12y plus 5x equals to 0. So that is the equation of the third side. So first what we'll do, we'll try to find out the coordinates of the point A. Coordinates of point A. Now in order to find out the coordinates of the vertex A, all you have to do is consider the sides that are opposite to the vertex A. Those are going to be the sides AB and AC. So if we solve the equation for AB and CB and CA, we're going to get x and y, and that is going to give us the coordinates of the vertex A. So when we solve for this, we are going to get x equals to 0 and y is going to be also equals to 0, which means that the coordinates of the vertex A is going to be 0, 0. Next, what we'll do, we'll try to figure out the coordinates of point B. So for this, what we'll do, we'll take the sides that are adjacent to the vertex B. So those are VA and BC. So BA and BC, that means we have to consider the side AB and side BC. We're going to solve these 2 equations, and that is going to give us the coordinates of B. So coordinates of B, that comes out to be, so x is going to be equals to 20 and y is going to be equals to 15, which means that the coordinates of B, that's going to be 20, 15. And similarly, we can find out the coordinates of the point C. So C can be obtained by solving the equation BC and CA. So BC and CA, the second and the third equation. So x comes out to be negative 36, and the corresponding y value comes out to be 15. So the coordinates of point C, that's going to be negative 36, 15. Okay, so now we have successfully obtained the coordinates of the endpoints A, B, and C. Let's do one thing. Let's also obtain here the values of the sides A, B, and C. So A, B, and C, that means A is going to be the side BC. So since we have the coordinates of the endpoint, what we can do, we can easily take the help of the distance formula to obtain the length of the side BC. So here BC comes out to be 56 units. Then we have the side B. B is going to correspond to CA. So CA, that is going to give us 39 units, and then finally C is going to be the third side, or the side AB, length of the side AB, so that is going to be equals to 25 units. So we have obtained the value of A, B and C such that, so here we can combine three of them because we'll need these three values, sum of these three values, that's going to be equals to 120. Okay, so first let us begin by computing the coordinates of the centroid. So let's find out the coordinates of the centroid. To find out the x-coordinate, all we have to do is take the sum of the x-coordinate of each of the vertices. So we have 0 added to 20, then added to negative 36, or simply minus 36 whole divided by 3. To find out the y-coordinate, we're going to take the sum of the y-coordinates of the vertices. We have 0 plus 15 divided by 3. So that gives us negative 16 over 3. That is going to be the x-coordinate of the centroid, and the y-coordinate is 15 plus 15, that's 30. 30 over 3, that corresponds to 10. So next we'll find out the coordinates of the in-center of the triangle. So let's first begin by computing the x-coordinate. So we'll start with A. So here A corresponds to 56. So 56 is going to get multiplied to the x-coordinate of A. So that's simply going to be 0 added to B. So B, we got it as 39. So B is 39. So 39 is going to get multiplied to the x-coordinate of the point B, or you can say x-coordinate of the vertex opposite to side B. That's going to be 39 times 20 added to C. So C, we obtain the value as 25. So 25 is going to get multiplied to negative 36 whole divided by A plus B plus C. We already obtained the sum is 120. And then the y-coordinate will be, so we'll start with 56. 56 gets multiplied to the y-coordinate to give us 0 added to 39 times 15. We have 39 multiplied to 15 added to C value, so that's 25. So we have 25 multiplied to 15 whole divided by 120. So let's simplify this, and this is going to give us negative 1, 8. So we have successfully obtained the coordinates of the centroid, which is negative 16 over 3, 10, and the coordinates of the in-center, negative 1, 8.